Kongre sir, good morning.
डफरे सर, मैंने वो लिंक भेज दिया है समीना को, यूट्यूब लिंक।
हाँ सर, हाँ ठीक, ओके। समीनाला पाठवली आहे यूट्यूब लिंक.
डफरे सर, we are ready. We can start as soon as the dignitaries are with us.
Yeah, sir. Within 5 minutes, Dr. Maulikar sir is going to join.
Yeah, no issue.
मम्मी का ग दीदी
Good morning to one and all participants who are being with us for this today national webinar. The Honorable Chairperson and the Chief Guest is going to join within a few minutes. So please be with us.
Hello, good morning.
Good morning. Good morning, Maulika sir. A very good morning. Namaskar.
Namaskar.
Namaskar, sir.
Good morning, sir.
Good morning.
Good, sir.
Dafre sir,
समीना मॅडम बोला, काय म्हणता?
तर चालू करू का?
बस फक्त 5 मिनिटात सर जॉईन करतील. आपण त्याच्यानंतर चालू करू. हॅलो, हा डॉक्टर समीना मॅम.
Yes sir.
The principal sir is going to join within 5 minutes, and he asked us to start the program. So all dignitaries are with us. Dr. Maulika sir already joined. You can start the webinar.
Okay sir. A very good morning to one and all. On the behalf of organizing committee, I, Dr. Samina Tadvi, Assistant Professor, Department of Chemistry, J.M. Patel, Arts, Commerce and Science College, Bhandara, welcome you all in the two-day national webinar on Green Chemistry for Sustainable Future, organized by Department of Chemistry, J.M. Patel, Arts, Commerce and Science College, Bhandara, under the DBT Star College scheme. Today, we have with us Dr. Vikas Dhomne sir, chairperson and very respected principal of our college, and Professor Dr. P.P. Mahulikar sir, senior professor and head Department of Industrial Chemistry and ex-pro vice chancellor of Kavitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon, as a chief guest and keynote speaker, and Dr. Gaurav Gupta sir, Assistant Professor, GTP College, Nandurbar, as a resource person for today's technical session first. Again, it's my proud privilege to welcome Dr. Vikas Gite sir, Associate Professor, Head, Department of Polymer Chemistry, Savitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon, will be with us for tomorrow's technical session first, and Dr. Amol H. Kategaonkar sir, Assistant Professor, मराठा विद्या प्रसारक समाज, करमवीर शांताराम बापू, कोंडाजी वावरे Arts, Science and Commerce College, Sidco, Nashik, will be with us tomorrow for technical section 2, and Dr. Shyam Dafresar, convener of the 2 days national webinar on green chemistry for sustainable future, and Dr. Karthik Panikar sir, IQC coordinator, Dr. D.I. Shahare sir, Head Department of Physics, Dr. Padmavati Rao ma'am, Head Department of Botany, and Dr. Veena Mahajan ma'am, Head Department of Zoology, all the faculties, dear students, and all the organizing committee members. I take this opportunity to invite Dr. Shyam Dafresar, convener of the 2-day national webinar on green chemistry for sustainable future, to deliver introductory remark.
Okay, thank you, Dr. Samina ma'am. Thank you very much. Good morning and warm welcome to all the participants. To this 2-day webinar on green chemistry for sustainable future. The chairperson of today's webinar, honorable and very respected principal of our college, Dr. Vikas Dhomne sir, is going to join within a fraction of minutes. And the honorable and very popular person in the field of HEI, higher education, and the eminent resource person who is with us as a chief guest and keynote speaker is Dr. Maulikar sir. He's a former Pro Vice Chancellor from Savitri Bahinabai Chaudhary, North Maharashtra Vidyapit, Jalgaon. Dr. D.I. Shahare sir, Head Department of Physics. My friend Dr. Karthik Panikar, Coordinator IQAC, Jempetal College, Bhandara. Dr. Veena Mahajan Madam, Head Department of Zoology. Dr. Padmavati Rao, Head Department of Botany. Dr. A.C. Shesh Ma'am, Head Department of Electronics, and all my faculties, budding researchers in the field of chemical science, and all participants and my dear students. And one, I'm very sorry to miss one personality again from the field of chemistry. We are having with us Dr. Nitin Kongre sir. He's a management counselor, RTM Nagpur Institute, Nagpur. He has also joined us. This webinar, my friends, is organized to bring about the awareness among the students and the young faculties for about the need of the green chemistry for the peaceful life, or you can say the sustainable future. Now, actually, from last 2 years, we people are very much suffering all over the world from the pandemic, and this pandemic has taught us a lot. And I think in the field of science and technology now must approach toward the sustainability in the earth or the planet. Being a human, we must now become cautious and take some steps for a good and healthy environment for the mankind and for the next generation. Being concerned in the field of the domain, I personally feel that green chemistry is a very important tool in getting or in having the achievement of the sustainability in the future. What you can say, the implementation of the green chemistry technology is very, very essential if the expanding population of the world, we can say, the expanding population of the world has to enjoy the increased standard of living without a negative impact on the health of the planet or the earth. And I'm sure green chemistry will definitely provide us a solution to global challenges which we are facing nowadays. For example, the climate changes, the pandemics which are coming in a round continuous fashion every day, every year, the toxics in the uh, environment, the toxic which are sprayed, the chemical toxics you can say, which are sprayed in the flora and the fauna, and the sustainable agriculture. From the platform of this webinar, I am very much interesting in that this is a time, this is a very crucial time. We must understand the importance of the green chemistry for a peaceful life, for a sustainability. Now, why this word sustainability carries a lot of information, because this year you people might have an idea that our government of India has declared this year for sustainability, and we must from this platform, from these eminent persons which have with us for 2 days, for today and tomorrow, everyone must learn, we must design, and we must need to what you can say, the interpret the green route to the traditional, or we can say a classical chemistry. We must now learn how to teach the green chemistry as a course in our chemistry laboratory. Every university, every board of study must have this green chemistry as a laboratory course to be incorporated in each and every curriculum of the whether it is a program of UG or whether it is a program of the PG. Lastly, we must feel, Maulika sir, what I feel now the green chemistry should become a social movement. It should be having weightage of social movement to create or build the environmentally commendable society, so that whatever the next generation which are coming to in this field, in the field of the chemical science, or in the field of the material science, or in the field of science and technology, they must approach, they must implement the green chemical technology, the green chemistry technology, from where we can at least dream today a better earth with a better environment, whatever the products which are going to obtain, which are going to discover in the field of science and technology, in the field of chemical science, in the field of biological sciences, that should be environmentally benign. There should not be hampered, there should not be any damage in the every micro level of environment, flora and fauna on the earth. I really extend my sincere thanks to Dr. Maulikar sir for being, he is very much kind to give a consent to be with us for this 2 days webinar. I'm also thankful to Dr. Gupta sir, who is a resource person for today's technical session 1. Dr. Geete sir, Dr. Katekau sir, who are the resource person for tomorrow's 2 technical session. I'm very much thankful to our Dr. Dhomne sir. He's the principal and chairman of the conference. He's always with us for such innovative programs. And all heads of the Department of the Science faculty. I'm special thankful to coordinator IQAC, Dr. Karthik Panikar, and all my faculty member, all participants who have shown the interest in being with us for this 2-day webinar on the green chemistry. I'm once again, thank you very much to all the members of the organizing committee. Thank you very much. Now it's over to Dr. Samina.
Thank you very much, sir, for your introductory remark.
Dr. Samina, just a minute. Sorry for interrupting. I think Dr. Dhomne sir having some time again. So Shall I request Dr. Karthik Panikar, sir, the coordinator of IQAC J.M. Patel College, to share some views? Panikar, sir? Okay.
Just a minute. Yeah, just a minute. Yeah.
Yeah, Dhomre sir joining, I think.
Yeah, I'm there. Okay. Yeah. You want me to speak, sir? You want me to speak? Yeah. Okay. Yeah. A very good morning to all of you. Am I audible to all of you? Okay. A very good morning to all of you. On behalf of the college administration, it's my privilege to welcome all the resource persons, dignitaries, the inaugurator and the keynote speaker, Professor Maulikar, Dr. Gupta, delegates who have joined us from different parts of the country, members of the faculty of J.M. Patel College, the core team that is working to implement the DBT Star College scheme under the able leadership of Dr. Dafre sir. As Dr. Dafre has said, green chemistry is the in thing. It is one thing that we need to invest a lot for our future generations. I'm not a man of chemistry, but I know that for us to have a good life, for us to have a safe life, it is very important that we think a lot about creating things which cannot be decomposed, which would remain on this earth for maybe 800, 900 years. Have its impact on the soil, water, and air. Because whatever we may earn, however rich we may be, but we must realize that if we have to if we have to survive on this planet, we will need good quality of air, good quality water, and of course, all the good quality food products that we get. It comes from the soil that we have. So we need to remember that we need to invest as much as in material things. As much as we invest in material things, we need to invest in developing green technologies for the future. There are so many things that we have nowadays. We are using it all the time. When we think of fuel replacing the rock fuel being replaced by EV technology, batteries, but we also need to think about what is going to happen to these batteries, how we are going to dispose of these batteries. After all, you need chemicals to run this battery, even these batteries. So we need to look at all those aspects, and I'm sure that we have very eminent resource persons who will be speaking on these topics. I as a layman can expect that the deliberations would go a long way in contributing in making this planet our life on this planet a very sustainable life. We hope to develop a green culture. We hope to develop green ethics. We hope to develop a green way of life. And I hope that is what this national seminar aims at. I wish all the success to this national seminar. Thank you so much for inviting me to share my views on this occasion. Thank you so much, sir.
Okay, sir. Thank you very much. I think this is not a lame comments. This is a very strong comments from the chamber of the coordinator of IPSC. Yeah, Dr. Samina, you can carry on. Dr. Dhomne sir has joined.
Thank you, Karthik Panikar sir. Now, may I invite chairperson and very respected principal of our college, Dr. Vikas Dhomne sir. He is always a source of inspiration and motivation for us.
Thank you, madam. I'm sorry that I am being late. for some reason. It is indeed a matter of great pleasure to organize this two-day national webinar on green chemistry for sustainable future by Department of Chemistry under Department of Biotechnology Star College scheme. We are meeting in the third wave of COVID-19, and the entire world is struggling through this third wave, but still the virtual platform has helped us to organize so many conferences, seminars to meet virtually to share our thoughts, to do some innovations. In the same way, we had also organized successfully a couple of days back an international e-conference on sustainable and futuristic material SFM 2021 on 29th and 30th of November 2021. I welcome Chief Guest and Keynote Speaker for the webinar, Dr. P.P. Mahurlikar, who is a Senior Professor and ex-Pro Vice Chancellor of KBC, North Maharashtra University, Jalgaon, for being with us as a Chief Guest, and all the resource persons for 2 days technical sessions, all the delegates, research scholars, academicians, the convener of this conference, Dr. Shyam Dapare, Head of the Department of Chemistry, the faculty members of J.M. Patel College of all the departments, the team members of DBT Star College scheme, and my dear students, those who are joined on YouTube. It has always been an endeavor of this college to promote the spirit of inquiry and culture of research and innovations. The policies and practices in this college are highly supportive of research and development. This webinar is aimed to exchange and disseminate new ideas, basic principles and discoveries of green chemistry to build up or step up towards promotion of sustainable development. Friends, green chemistry plays a very important role in our life. In our campus also, we always say that our campus is a green campus, it's an environmental friendly campus. The entire world is suffering by climate change, the global warming, and there the role of green chemistry plays. I am sure that this webinar will provide a unique role in mapping the way ahead for humankind progress. It is time to have such a webinar, workshop, and conferences amongst the academicians, researchers, teachers, aspirants, students, and entrepreneurs to promote the adoption of green chemistry technology to develop sustainable society. I hope that this webinar will be a meaningful one, a relevant, purposive, interactive, and will prove an excellent platform for dealing with all issues related to environment and sustainable future. I congratulate all the participants and the organizing committee of webinar and wish them a good luck for the success of the event. Thank you very much. Over to you, Madam.
Thank you, sir. Thank you very much, sir, for your guidance. It's always roadmap to success for us, sir. Now, it's really a matter of pride for us that today we have Professor P.P. Mahurlikar, sir, Senior Professor and Head Department of Industrial Chemistry and ex-Pro Vice Chancellor of Kavitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon, as a chief guest and keynote speaker. It gives me an immense pleasure to introduce Professor P.P. Mahurlikar, sir. P.P. Mahurlikar, sir, has 28 years of teaching and 33 years of research experience, and total 190 research papers were published in international and national journals of high repute. 4 patents, 7 articles, and 7 books to his credit also. He has Google Scholar citation more than 4,286, Scopus citation is more than 3,292. Under the supervision of Professor Mimi Mahulikar sir, 26 research students have been awarded PhD degree, and currently 3 PhD students are working and 1 student is working as a postdoctoral fellow. Till the date, sir has completed 12 research projects of total grant 2.80 crores. He is having more than 12 awards in the field of research and academic to his credit. Sir also has administrative experience. Sir worked as a head department of pesticides and agrochemicals in KBC NMU Jalgaon. Sir also worked as a director, School of Chemical Sciences, KBC NMU Jalgaon, and Sir also worked as director, Board of Colleges and University Development, that is BCUD, NMU Jalgaon, and he was co-vice chancellor of Kavitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon. Now, may I invite you, sir, to bless with your kind words. PP Mahulikar, sir.
Thank you very much, Dr. Samina, for nice introduction and inviting me on behalf of your college and authority, then secretary and chairman of the college for this 2 days national webinar on green chemistry for sustainable future. At the outset, I am very much thankful for invitation and organization of this webinar on a very good theme, that is a green chemistry or sustainable chemistry. So I appreciate the efforts of your leader, principal of the college, Dr. Vikas Dhomne. Just he has given address including importance of green chemistry, as well as he has mentioned that campus is also maintained green and environment is totally green in this college, and it has been reflected by the your NAC re-accreditation. You achieved B grade, but most important that were to mention here, your college has achieved the potential of excellence by UGC for phase 2, as well as Center for Higher Learning and Research recognition from your university. Good things that you have achieved with your staffs and colleagues. Then the Department of Chemistry is under DBG Star College scheme. Is also one more good thing. Then our Government of India DBT has also awarded Star College status for your college. It clearly implies the whatever going on the college, that is according to or for the benefits of students and overall development of students and the college as well as our nation. I already appreciated that college has organized this webinar on good theme, green chemistry for sustainable development or sustainable future. Number of points have been covered by convener Dr. S.W. Dapre. What is the importance of green chemistry, what we should do to maintain the environmental, that to reduce or minimize the environmental pollution and all things. Dear friends, actually the delegates or participants are mostly the research students and PG students. So I will enlighten them on the history and development of green chemistry. What is this important? Just I will extend the content as already mentioned by Dr. Dapre. Then what is green chemistry? This is the one more branch or future of our conventional chemistry that we are performing today. Green chemistry has been introduced in our conventional chemistry, or this term has been coined by Paul T. Anastas. So in my lecture, I will deliberately talk more on two personalities. And these personalities we have contributed a lot in the development of this green chemistry or sustainable chemistry. Dear friends, your college principal just mentioned about the COVID-19 crisis. This is the third wave. On 11th, actually, whatever that virus named the corona has started its influence or impact since November 2019. And that impact was more since January 2020. And that's why on 11th March 2020, World Health Organization has declared this COVID-19 as a pandemic disease. Immediately after a few days, on 23rd March, our government of India as well as state Maharashtra government has declared pandemic situation in our country as well as in our Maharashtra state, and immediately they implemented a lockdown. As just after the implementation lockdown, our regular teaching learning process had been totally stopped, and number of disturbances in the dissemination of knowledge to the students that we are facing since that time. But on the other side, we have grabbed an opportunity to continue our teaching learning process online through various modules and medias. But online education has a number of drawbacks that we have experienced since last more than 1.5 years. The face-to-face teaching learning process is effective, but number of limitations for online teaching learning process. It is another aspect, but number of colleges and universities have also grabbed that opportunity to organize webinars, seminars, workshops for 7 days also to disseminate the knowledge to the delegates or participants through eminent personalities. As we are organizing all these seminars, webinar online, number of eminent personalities are easily available from their places, and they have shared their knowledge through this online teaching learning process and organization of webinars, workshops, and seminars. Your college has been organized a webinar on green chemistry. It is a future chemistry. Now we were talking green chemistry as a future chemistry up to 2015. But now we should say that green chemistry is a present chemistry, not future. Today we have to implement successfully the greener approach at each and every phase of our teaching learning process, including practicals. Coordinator of IQAC, Dr. Panikar, has also mentioned that we should implement green technology. Also, Dr. Dapre has also emphasized on the implementation of green technology at practical and research level at colleges as well as universities. Number of universities has already taken a step forward for the application of greener approaches. They have included certain aspects in their curriculum. But it is my opinion that now we should design 1 or 2 courses at UG level, SY and TY, BSc, and for PG level, for MSc, we have to design more than 5 courses on the green chemistry. All before 2030, in this decade, we have to start at least 1 PG course on green chemistry or sustainable development, as our another discipline like organic chemistry, inorganic physical chemistry in this. So it will be better if you achieve that step by implementing separate course on green chemistry by 2030. And it is not difficult. Now much more topics or aspects already we have included at UG and PG level. So we have to encourage all teachers, researchers, and this young generation, especially those who have entered in the science stream, and more especially those who have entered in the chemistry subject. Dr. Dapre mentioned that now we should consider green chemistry as a social movement. Definitely, we should go for. But again, one step ahead, I can say that it should be a chemistry teacher's mission at each and every step. That chemistry teachers should think about green chemistry. So green chemistry should be a chemistry teacher's mission now. Then and then only we can achieve the 30, 40, 50% of greener approach at UG level and PG level. And by 2030, we can achieve up to 90% this green chemistry curriculum at PG level, definitely. So it should be mission for chemistry teachers and chemistry researchers, and we should act as volunteers to create awareness of greener approach or sustainable chemistry or safer chemistry or eco-friendly chemistry or environmentally benign chemistry, to create awareness among these researchers. And we should make it mandatory for practicals as well as research at our lab, at colleges and university. Then and then only we can achieve our target. Otherwise, just talking in the workshop, in seminars and webinars, that we should do like that, we should perform like that. Instead of implementation is most, or it is most important. So we should take steps immediately while designing or revising our curriculum. So we should start the introduction of the basic aspects of green chemistry from FYBSc, one more aspect in SYBSc, and in TYBSc, some again more aspects. And at PG level, we should design, we should start the designing of the special courses and papers on the green chemistry. And by 2030, our university, all universities in Maharashtra should initiate the MSc in green chemistry or MSc in sustainable development. This goal should we keep in our mind, and then only we can achieve our target. So chemistry teacher mission's goal is now there will be MSc in green chemistry or MSc in sustainable chemistry by 2030. So by we have to do for that achievement by 2030. So keeping in mind this our target, our mission should be initiated immediately at our colleges and universities. Then and then only we can achieve this target. So once again, I congratulate all the team of college, especially patron of this webinar, secretary of the Gondia Education Society, Sri Rajendra Jainji, principal of this college and chairman of this webinar, Dr. Vikas Dhomne, convener of this webinar and head of the Department of Chemistry, Dr. S.W. Dapre, organizing secretary, Dr. Samina Tadvi, coordinator of IQSC, Dr. Karthik Penikar, and all other staff, teaching as well as non-teaching staff, who have put their efforts for the organization of this seminar on nice topic of green chemistry for sustainable future. So once again, I congratulate the team of Gondia Education Society's J.M. Patel Arts, Commerce and Science College, Bhandara, for organizing such a nice event in the benefit of the young generation to create awareness about the green chemistry. And definitely that will be very helpful for the delegates and participants to get idea about the greener approaches or what is a green chemistry for the minimization of all kinds of problems, not only environmental problems, but all kinds of problems that we are facing since last many decades. So with this bit, again, I congratulate you all for organizing this 2 days national webinar on this green chemistry for sustainable future. Thank you very much. असंच ठेव ना. हॅलो.
Hello, thank you, sir.
काय झालं? नाही स्क्रीन. Just 1 minute. I am sharing my screen.
Okay, sir. Okay.
I think it is visible now. Yes.
Sir, yes.
Okay. So shall I start now?
Yes, sir.
Okay. So at the outset, again, I thank the authority of college, principal, convener, then organizing secretaries, IPH coordinator for giving me opportunity to interact with the young researchers and the PG and UG students. We have participated in this national webinar on green chemistry and for green chemistry for sustainable future. So on this occasion, I would like to take this as an opportunity to introduce all delegates with 2 personalities from America, USA. First is a Rachel Carson, second is a Paul Anastas. How they have worked, how they have devoted their work life in the development of green chemistry. So these are the 2 persons of today's my lecture, and I will give a brief account of bibliography of these 2 people, so that young generation could get idea about the their work in the development of green chemistry. First personality is Rachel Carson from USA, and second is from also USA Professor Paul Anastas, who is called as a father of green chemistry. Dear friend, this picture gives idea about the importance of chemistry. How chemistry is important for our life. At each and every moment, for each and every activity, for each and every work, we require chemistry. This picture shows food material, agriculture, medicines, beverages, space research, then nanotechnology, and all things that totally based on the chemistry. So without chemistry, we can't do anything in our life. So considering the importance of chemistry, we have developed a number of chemical industries, and that resulted in the unpredicted result, that is environmental pollution. That I will give timeline, how we have started industries, why we have started industries, and from which year we actually detected, or we started the facing of environmental problems. So considering the importance of this chemistry in our life, this picture shows actually initiation of agriculture practices on this earth. It is believed that after the formation of earth and development of the forest on this earth, our earth was very green, deep, dense forest was there. And when man started the practicing agriculture or agricultural practices, when he started, then first step was the deforestation. Just by removing the trees, shrubs, and plants, he started the development of agricultural land, and he started the agricultural practices. And it has been documented that on this earth, first agriculture practice was initiated by a Japanese lady named Nati. And it has been noted 8,000 before Christ. Means more than 10,000 years have been passed for our agriculture practices on this earth. This another timeline is given, but I will not go in detail. So just after agriculture practices that we started on this earth, then because of the increased number of population and demand for various articles, various materials, various products, we started the industries. And actually, up to agriculture practices, there was everything was okay. Only one factor was negative, that was the deforestation. But whatever forest was available, that was sufficient. But in second phase, when man started industrial practices, and this is the step, that was the second step, which was started by man for as per the need and demand of the increased population. And this was the step which was the first step towards the environmental problem. So man started agriculture practice, then industrial industries he has started, and that total activities violated our nature, and that has been resulted in environmental pollution and ecological damage. And this is the important step that in the history for the environmental problems. The basic cause of environmental problem we see, as I said, first agriculture practices, deforestation. Up to that step, there was no problem. But just after starting the industrial practices, we actually that problem we have not noticed up to 1960. But before that, industry has much released noxious or adverse chemicals in the environment. And if you see the basic cause of environmental problem, not only the need of man or increase the population for various products, materials and purposes, but one more thing, our way of life, our luxurious life, especially in the developed country, that is the main reason. And second is the consumption of huge volumes of resources. Whatever resources are available on this our earth, that we are consuming more than our need. Our greedy nature is mainly responsible for the environmental problem. And third one, that is the most important, when we initiated industries, the main factor or main problem that we are facing since last more than 30 years, that is the waste. Unnecessarily, we are creating waste through various activities in various industries. So this is the basic reason for the environmental problem that we are facing from more than last 40, 60 years. Then under development or agriculture practices, number of inorganic and organic compounds were in use to control the pest problem. This is one more additional information that which material that we were using as a pesticides in old agriculture practices. Then during the World War II, first compound which was synthesized was a DDT. That Muller synthesized in 1930 DDT, and then BSc was actually synthesized in 1825. That I will give brief on BSc. And since 1944, we started the synthesis of the biodegradable pesticides from organic class, organophosphates, then thaliamides, then some herbicides, even we synthesized organochlorine compounds, and most common organochlorine compounds were two organochlorine compounds. One was BSc and other was DDT. If you see the structure of benzene hexachloride, BSc, actually BSc, what Michael Faraday in 1820 was trying chlorination of benzene. Just in the benzene, he bubbled the chlorine gas, and it was a exothermic reaction. And just after chlorination of benzene, he obtained a solid mass. Whatever mass obtained, he named that compound as a benzene hexachloride, having formula C6Cl6. But after 11 years, another chemist determined the correct structure for the product which was synthesized by this Michael Faraday. And that was not benzene hexachloride, but it was a hexachlorocyclohexane. And molecular formula is C6Cl6. And this is the compound which was synthesized by Michael Faraday in 1825. Correct structure assigned to this compound in 1835. And after more than 110 years, its compound's activity was determined as an insecticide in 1942. And that period was the Second World War period, 1939 to 1945. And in 1939, one more compound which was synthesized by Muller was a DDT. And these two compounds actually we have used abundantly for the control of public health pests. Before that, when we started the industries for the synthesizing number of chemicals, products, compounds, reagents, then according to the generation of waste, these compounds have been segregated in 4 categories. And that if you see the first column, this is a type of industry: oil refining, bulk chemicals, fine chemical, pharmaceutical. These industry producing these compounds, the tonnage of product required or production. And last column, it is a E factor. It is one of the principle of green chemistry, that is efficiency factor. How much reactants are converted into product, that is called as efficient. We are expecting 100% efficient synthesis, but we can't achieve that 100% efficient synthesis by number of problems that we'll discuss. So third column is the E factor, which can be calculated by kilograms of products divided by byproduct divided by kilograms of product. So byproduct divided by product gives idea about the E factor of this chemical synthesis or manufacturing process. Minimum E factor, less waste generated. Maximum E factor, maximum waste generation. So if you start from oil refinery, then oil refinery, gases, volatile liquids, all portions have been separated, fractionated, and whatever remains residue, that is a tar, that is also used for the number of purposes, main purposes, road construction and all. So whatever the E factor for this oil refined, that is a less than 0.1%. Bulk chemicals that has been actually given in red color. What are bulk chemicals? Bulk chemicals are the chemicals which are never purified after their manufacture. We don't consider the purity of this compound as we are not using for the human being, that are used for other purposes. The best examples under bulk chemical, pesticides, fertilizers, paints, varnishes, and all things that are not used directly for human being. That's why we don't bother about their purity. Most important class from bulk chemicals is the pesticide and fertilizer. Pesticides are toxic compounds. Though they are toxic compound, we never think about their purification. So bulk chemicals means chemicals which are never purified. So in that bulk chemical, depending on the byproducts, that E factor is about 1 to 5. Or simply we can say that for 1 kg of product, there may be maximum 5 kg of byproduct. Then fine chemicals, in terms of, in chemistry language, fine means pure. Fine means pure. And about bulk chemical means, bulk means more amount without purification. And fine chemicals mean pure chemicals, the chemical that we use in our laboratory for practical purposes, research purposes, as well as in industries, that comes under fine chemicals. See the E factor for fine chemicals, it is up to 50 or more than 50. Then fourth class of chemical, that are pharmaceuticals. These chemicals are only used for human beings, and that's why we take proper care that they should not show any side effects or unwanted reactions. That's why we consider the purity of pharmaceuticals or drugs more than 99.99%. So repeatedly they are purified from, and mother liquor is generated and waste is generated more and more. And see, for 1 kg of pharmaceutical product, more than 100 kg byproduct may be formed. So these are the E factors, and according to E factors, we can categorize the chemicals in 4 categories as oil refining, bulk chemical, fine chemical, and pharmaceuticals. In our in this lecture, my more interest is on bulk chemicals, and from bulk chemicals, I will talk about the pesticides, and that's why I have taken these 2 compounds that have been actually these 2 compounds are more responsible for environmental pollutions since 1940. See, DDT, Paul Muller has synthesized DDT in 1939, and because of its more activity as insecticide, this compound DDT was honored, or the Paul Muller was honored with the Nobel Prize in 1948. Second compound, which was primarily synthesized by Michael Faraday in 1825, but it was identified as an insecticide, and we started the use of BSC in our routine practice as insecticide from 1942 to control the public health pest. And from 1940 to 1960, almost for 20 years, we have used these 2 compounds non-judiciously or samanjaspane, without bother considering anything, because that was the period. In that period, nobody was thinking about the adverse effect, toxic effects of chemicals, and nobody was believing also that certain chemical can exert that type of adverse effects or harmful effects. And that's why, because of ignorance, we have used these 2 compounds, DDT and BSC, and these 2 compounds are organochlorine compounds. Our organochlorine compounds are persistent in nature. They are not degradable, and they can remain for more than, or in 100 years, more than 1000 years also. And it is scientific prediction that even today, that DDT has already been stopped. That has banned throughout world. In India in 1972. BSc, it has been banned in 1998. But whatever amount product that has been manufactured up to 1998, it is available in the market with less formulation percentage of formulation, which was available earlier as a 30% dust, 30% powder. Now it is available as a 1.65% EC or 1.30% EC or 0.65 EC or powder. That its amount has been totally minimize to avoid the harmful or adverse effect. And for 1994, organochlorine, organocarbamates, then herbicides and other classes of number of compounds we have synthesized, keeping in mind the degradation of compound after application. And that effective period may be 1 week, 2 weeks, but after that period, that compound should be degraded. So by considering this principle, we have synthesized number of compounds. But whatever amount we have used in 1940 to 1960, DDT and BSc, these two compounds are mainly responsible for environmental problems. So whatever environmental problem we consider, that is 70% environmental problems are because of chemical compounds. And among the chemical compounds, more than 70% contribution is by two compounds only, that is BSc and DDT. This is about chemical compound that we have used abundantly, non-judiciously for more than 20 years. Now, up to 1960 we have used. Then before that, we will see the biography of first personality, that is Rachel Louise Carson, who is a lady from USA. She was born on May 27, 1907, Pennsylvania Springdale area of USA. She was a girl of forest officer. Her father was forest officer. So she was living nearby nature, forest, and she was enjoying living in the nature or in the forest since her childhood. And she was fond of nature, springs, birds, animals, water, forest, and all things. And since the childhood, she has one good habit. Whatever she was observing in that day, she was noting all observation in her notebook at night. And main inspiration was of her mother. Her mother taught her to write the notes or notation what she has observed or she had observed on that day. So he had a good habit to note down all things or observations of that day in the notebook. In 1929, she qualified graduation in zoology. Then she had already interest of writing as she had observation on wildlife, nature, and forest environment. Then she received one fellowship, that is World Whole Marine Biology Laboratory Fellowship for the PG program. And then she completed her post-graduation in zoology from Johns Hopkins University. And she had actually more interest in the research. But what happened, just after completion of her post-graduation, her sister was died, and her sister had kids. And because of the responsibility of these sister children, she did not continue her research after PG, and she actually engaged in the education of the sisters' children and their care. And actually, by that time, she had a problem of money also. So she stopped her further education and research. But fortunately, she got one fellowship from United States Bureau of Fisheries, and then she continued her research. And as I said, she had a good habit to write down the observations of each and every day, what she had observed from morning to evening. At the night, she was noting that all notation, writing all notations in the notebook, and on the basis of that notations or documents, she published one book in 1941 under the sea wind. Second book she published just after 10 years, 1951, Sea Around Us. And these two books were found to be very popular books in the market. And she received a National Book Award for the second book, that is The Sea Around Us. And then she got some money, and then she again fully engaged in the research as per her interest. Meanwhile, what happened at during 1955-56, she received one letter from her friend who was living nearby area, and that friend conveyed her that because of unknown reason, the birds are dying day by day in our region. I know you are doing research in this fisheries and the chemical toxicology and all things. So it is my request that kindly spare some time and come to my area to find the reason behind the death of birds. Then she shifted for 2 years in that area where her friend was living, and she actually continued her research for more than 2 years. And whatever results she obtained, that all results she compiled well, and she drafted in the form of book, and she sent that all draft to the editor of Reader's Digest. Reader's Digest is one of the common book published throughout the world that contain information of all disciplines and subjects. After reading that result submitted by Rachel Carson, the editor refused that draft to her, and she showed his inability to publish this work, as he was also not believing in that result. Then she tried for one more, 2-3 publication companies, but nobody was ready to publish. And in 1962, after 1 year, Hatton Mill Film Company, that editor accepted that draft which was prepared by this Rachel Carson, and it was published in the form of book. And the name of that book was A Silent Spring. This is the book which was published in 1962. And this was the first report that was including the information about the harmful or adverse effect of chemicals on human being or in water bodies or aquatic species, on animals or overall environment. Before that, there was no any report about adverse and harmful effect. So this book was found to be a revolutionary book in 1962. And this book was mostly opposed by industrialists, as they were synthesizing this type of compounds. So they totally opposed the publication of this book. Then it was a book of debate among the scientists and chemists throughout the world. Then by that time, then President of America was John F. Kennedy. He was a man with scientific background. When he heard about this book as it is found to be a revised book, he asked himself one copy of book, and just he went through that content, and immediately appointed a senate of 11 scientists to observe, to check the results that have been reported in this book by Rachel Carson, whether these are true or false. Just within a 6 months, that 11 scientists senate submitted report to the principal John F. Kennedy that whatever reported by Rachel Carson in this book, Silent Spring, it is 100% correct. Immediately, that Senate was converted into Scientific Advisory Committee, and he ordered to that committee that not only the chemicals which was studied by Rachel Carson and reported in this book, Silent Spring, but you all people have to study each and every chemical that we have synthesized and we are using for various purposes, for their chemical and physical properties as well as adverse effects and environmental effects. And that committee started their work from 1965, and same committee was then named as the Environmental Protection Agency in 1970. And actually it works since that year, 1965, and after its name as the Environmental Protection Agency 1970. Since that year, this committee works on works for the checking of chemical physical properties of each and every chemicals, reactant, catalyst, reagents, solvents, and all things, even products, even reaction conditions also. All that committee checked, and it gives some regulations, rules for next purposes. So this was the main outcome by that Senate, which was appointed by John F. Kennedy. Then before that, I will show the books which were published by this Rachel Carson. The first book, as I said, in 1941, Under the Sea Wind. Second book, A Sea Around Us, 1951. The Age of the Sea, 1955. If you see the titles of books, then we can get idea about the content of material in these books. And fourth book was Silent Spring, which was published in 1962. In 1964, Rachel Carson was died on April 14 in 1964. But a number of notes were available even after her death, and their family member decided to publish that notes in the form of books. And after her death, the fifth book was published in 1965, just after her death, after 1 year. Sense of Wonder. Whatever notations remain to publish, that family members published this book under the title Sense of Wonder. Our main interest is the fourth book, Silent Spring. And this was the first book which was containing the adverse, harmful, and unexpected effects of chemical compounds in environment, on humans, birds, animals, fish, and all. The title Silent Spring. Silent Spring in Marathi, it is called as a Muk Vasant. Spring is actually it is spring actually comes in March, that we celebrate our first day of Marathi New Year, that is Gudi Padwa. From Gudi Padwa, we celebrate New Year of our Marathi New Year. In March, that spring comes. Everywhere nature gets blossomed with leaves, flowers, and colorful flowers everywhere. And that is the spring in Marathi we call as Vasant Rutu. And that because of chemicals, that the blossoming of spring we have totally inhibited, prohibited, and we have made it silent. And that's why it was a appropriate title given by this Rachel Carson in that year 1962. That is a silent spring, that is a Muk Vasan. Marathi edition is also available in market for this book, that is silent spring. Very interesting to go through this book. How it is beyond our imagination. If you see the period of research by Rachel Carson, it was during before 1960 and book published in 1962. By that time, there were no analytical tools as per our as we have today available, that all sufficient instruments. That period was not that much rich by instrumentation or the tools which are required for the investigation. In that period, she worked or devoted her life to find out the adverse effects of chemicals or exact reason behind the death of the bird. As I said, that her friend invited her to check or to find the reason behind the death of birds in his region. And accordingly, she worked for more than 2 years in that region. And whatever observations, that observations all she compiled and published in the form of book, that is a silent spring. This is the picture that shows egg and eaglet of eagle. I will talk on later on. First, in 1962, as I said, this book was found to be revolutionary. The step taken by John F. Kennedy resulted in the formation of environmental protection agency, that is Environmental Protection Agency, EPA, from Presidential Advisory Committee, before that Senate. So Environmental Protection Agency, which came into force to check or to form the regulations to control the environmental pollutions. In 1962, two major decisions were taken after publication of this silent spring. In 1962, there was one conference at Geneva, and number of scientists from all corners of world were gathered in this conference. And in same year, as this book was published and was found to be revolutionary book, this book was totally thoroughly discussed in that conference at Geneva. And considering the importance of these results that we included in the book, the scientific community took two decisions in that conference immediately, that now it is necessary to study the environmental problems separately from discipline chemistry. Because of this wider aspects, and that committee took a decision to study environmental sciences separately from chemistry from 1962. And since 1962, we are studying environmental sciences separate. Then that committee constituted or formulated Act on Pollution Prevention. This was one more achievement, that is a Water Pollution Prevention Act, Air Pollution Prevention Act, Soil Pollution Prevention. This Pollution Prevention Act have been constituted, or that decision was taken in 1962, and that all acts were then elaborated after 1990, when actually green chemistry initiated in 1990. So these are the two major achievements because of the work which was carried out by Rachel Carson and published in the form of book. So see the devotion of this Rachel Carson, how she devoted her life in finding harmful effects of chemicals and publication of this book, and that outcome of that her work was a separate branch of science, environmental science and Pollution Prevention Act. So these are the two major achievements that we got from this work of Rachel Carson. This photograph shows a guy
I think there is some network issue with Dr. Maulikar
Yes,
sir.
I suppose it is from Maulikar sir's end.
Yeah. Just from.
Yeah. I think it should be back in 5 minutes. There must be some issue.
Yeah, exactly.
Can we just try and contact Maulikar?
Sir,
He's
sir.
back. Yeah, he's back. Yeah.
Hello, sir. Hello,
Yeah,
sir.
yes, sir. Yeah, clear.
Yes, sir.
Power failure issue. Power failure
Yeah, I
issue.
can understand, sir. I
Okay.
can understand.
Yes, sir. Please
You
carry
can
on.
contact to Maulikar, sir. He may switch on laptop or something.
okay. Okay. Hello.
Sir.
Yes, sir. Please proceed, sir. We
Yes,
can
sir.
see your slides now, sir.
Okay. Because of power failure, just I joined again. So we will continue our talk on this greener approach. I was talking on the work carried out by Rachel Carson and outcome silencing in the then two outcome because of silencing publication. First is the environmental science branch that we are to study separately from chemistry since 1962 and formulation of prevention of pollution prevention acts. This picture gives idea about the work of Rachel Carson. Rachel Carson found the exact reason behind the death of birds. The eagle species was the largest species on this earth, but now it has been totally vanished by two compounds only, that is BS and BD. As we have used these two compounds since 1942, 1960, 20 years, abundantly, non-judiciously, without thinking, because that period, in that period, nobody was knowing that certain chemical compounds. And that's why we used these two compounds for the control of public health. And if you see the picture in that old pandemic situation, these two compounds were applied over the city to control the pandemic situation through the craft or plane. And if you see the picture, photograph of that city, just like a snowfall, just you can imagine how much metric tons of compound was spread over there and how much compound was inhaled by then people or animals or birds, how much compound actually up in the water bodies. So the reason behind the death of bird was that the generation of birds is continued by laying egg and then incubation, then hatching of that egg give the birth for the offspring. While forming this egg within the body of female eagle, when eagle species was exposed to the DDT and BSC, the compounds entered in their body, and these two compounds are lipophilic in nature. Lipophilic means soluble in lipids, fats. They remain as such in the body, and after saturation or accumulation of certain amount, they show their adverse effect. What actually this compound, after entering the body of eagle female bird, they stopped the activity of enzyme. That enzyme was supportive for the deposition of calcium during the formation of shell, outer cover of the egg, that is a shell with a calcium deposition. And that mechanism was totally inhibited by these two compounds, BS and DDT. The egg was formed in the body of God, but outer layer was not that much tough. And after laying, as outer layer or shell was not tough, the incubation process not followed. And because of not proper incubation, the birth of living offspring was continued. And this was the main reason that why eagle species have been totally vanished. More than 1,000 species of birds have been vanished by these two compounds. That has been documented. If you see the list of bird species vanished by these two compounds, BS and DDT, it is highly surprising that we can't imagine that these two compounds have done that much effect or impact on the environment. And number of species on the edge or at the alarming stage because of this toxic compounds. Now we are not using only pesticides. Number of other chemicals from other different classes we are using in the various applications, and that we are releasing all these compounds in the environment. Fortunately, we have stopped CFCs that we were using for fishing or for cooling purpose. Now number of alternatives are there. And this is the outcome by this publication of Silence Scream book by Rachel Carson. Now second person, how he has also devoted for the development of shaper chemistry for us. Paul T. Anastas, who is called as a father of chemistry. Before that, when in 1962, Rachel Carson published this book that is a Silence Spring, we started the study of environmental science separately from the chemistry thing. But during 70, when people know about the environmental problems, the common people also came to know the environmental problems, and through all corners of world, people blamed the chemistry people or chemists as a culprits. These are the people who are mainly responsible for these problems, environmental problems. They have synthesized a number of toxic compounds they have used and all things. But same people who were blamed as a culprit in 1970, after that Environmental Protection Agency, EPA, after constitution of EPA in 1970, immediately we implemented certain rules and regulation to minimize the application of toxic and harmful compounds or direct release of these compounds in the environment. And more awareness was created after 1990 when Pauti Analysis introduced the green approach in chemistry. So the chemist people who were blamed as a culprit in 1970, the same peoples have solved the problems. They have searched for the substitute for harmful compounds, reagent, catalyst, and since 1990, we are achieving much more positive results regarding environmental pollution. and we got first result in 2005. That was a very good news for the world that ozone layer is repairing. The ozone layer was depleted because of this some pesticides and mainly by CFCs, chlorofluorocarbons. If you see the primary member of alkyl halide, methyl bromide, that we use as a fumigant for fumigation of food factories, industries, and food products also, storages also. This methyl bromide, in world practice, while considering the fumigation by methyl bromide, after fumigation, that methyl bromide was allowed to release in the environment. But after knowing that one molecule of methyl bromide destroys 30,000 molecules of ozone. After knowing this, immediately we stopped the release of methyl bromide in the environment. After fumigation, our Pest Control India is the leading company in the India who actually perform the practices of fumigation by methyl bromide. Now methyl bromide, whatever methyl bromide applied for fumigation, it is sucked back as such for purification, but not released in the environment. Total CFC we have totally stopped, and now we have number of substituent products and materials are there, and that's why no harmful gas or vapor or chemical compound we are releasing in the environment which is harmful to the ozone layer or other harmful effects. So in 2005, the first report when came as ozone layer is repairing, that was a good news for world. And this has been achieved by the same people which were actually blamed as culprits who are mainly responsible for environmental problems. That same peoples have solved the problem of environment, and now we are on the right track of using our chemistry. But though we are on the right track, we have searched for substitutes and other harmful products and chemicals. But if you see the today's conventional chemistry has again number of drawbacks. And Paul T. Anastas has actually contributed to remove these drawbacks. This fellow, Paul T. Anastas, he is the director of LA University Center for Green Chemistry and Green Engineering at USA. He was scientific advisor for the United States Environmental Protection Agency. He was a member of that EPA also. Then he was appointed as assistant administrator or scientific advisor for the former president Barack Obama. For 2 terms, more than 8 years, he was and solutions. And the Paul T. Anastas was also one of the member in Environmental Protection Agency. And when Environmental Protection Agency started the work in 1970, to check the, then Paul T. Anastas also studied separately all these chemical compounds, reaction conditions and products, and he formulated certain rules. He formulated 12 rules to minimize how we can reduce the environmental problem or to reduce the release of chemicals in the environment in any form, gas, vapor, or in sublimation form, solid phase, or any form. That rules are called as, he named as the principles of green chemistry. And that's why he has, as he constituted 12 principles of green chemistry, for the first time, he is called as a father of green chemistry. And because of his efforts, what work he has done, now what we are observing, that is the minimization of environment by adopting greener approaches. That is a very fruitful for us. overall to minimize overall environmental pollution because of was of 70% contribution was of chemical compounds, and among the chemical compound, more than 70% contribution by pesticides, and among the pesticides, more than 80% contribution by two compound BSC and DDT. Fortunately, we have banned the DDT in our country in 1972. Even BSC has been also totally banned, but whatever available that may be available for more than for more 2-3 years only, and that will stock will be then vanished. Then this person, when he constituted 12 rules, that 12 rules are called as the principles of this green chemistry. Number of work in green chemistry has published a number of books, more than 100 publications in his credits on good greener approaches. So Paul T. Anastas's achievements, the 1998, the President's Hammer Award to 2011. See the coincidence. In 2011, he received one award for his work to minimize the environmental pollution by constituting the principles or rules. If we follow these rules, we can achieve greener approach, ideal synthesis in this way. So he achieved environmental award in the name of Rachel Carson, who actually worked in before 1960. Adverse of or harmful effects of chemicals, and she published that book Silent Spring, and in her name he received that award in 2011. She first people's, that is a base for this environmental protection, and second people also devoted his life to minimize environmental pollution, and he is receiving the award in the name of the first person, that is a Rachel Carson. This is a very good coincidence or nice coincidence in the history of the environmental pollution prevention or history. So these are the number of books, list of books that are available on internet, also online. Paul T. Anastas. These are the first the books that published by this Paul T. Anastas with his colleagues. So Paul T. Anastas defined the sustainability. What is the goal of our green chemistry? Goal of our green chemistry is to achieve sustainability. What is sustainability? Meeting the present generation without compromising the need of future generation. Whatever available on this earth, definitely it is our right to use that all resources and whatever available, but we should use that judiciously to meet our needs, not greeds. We should not go beyond our needs, but we need that is our readily available in the nature. But because of greediness, without compromise, we should compromise. We should keep in mind our need. So we should avoid it, and this is our reason. That we can achieve through the green chemistry. Through green chemistry, following 12 rules that have been given by Paul T. Anastas. And this was the first page, which was uploaded by Paul T. Anastas on his website in 1990 for the first time. And these 12 rules, if you start, I will go fast now. Prevention. In our real side, I have shown on this earth, agricultural practices resulted in the deforestation, industrial practices, that is, they violated our nature, environment. They unnecessarily we have kept our burden on natural resources. And third thing was the waste. Waste is the main headache throughout world now because of generation of unwanted waste in number of activities of man. So our first aim should be to prevent the generation of waste. At least we have to minimize the generation of waste. There is no need, but we have to prevent. If you get success in the prevention of waste, then it is 100% the ideal work without harming our environment, and it is good for future generation also. Then atom economy, number of atoms which are present in the reactant should be exactly equal number of atoms in the product. Otherwise, byproduct formation is not allowed or accepted in this green chemistry. Less hazardous chemical synthesis. We should design synthesis by using less hazardous chemicals, and we should go forward for the safer synthesis. Designing safer chemicals. Whatever product we are synthesizing, that should be totally degradable or safe to the environment. Then and then only we can give permission for the synthesis, otherwise not. Safer solvents and auxiliaries, that we will see the list of safer solvents and auxiliaries. Which solvents are now accepted under green chemistry and which solvents that we should avoid. All reactions, synthesis or manufacturing process, we should achieve with the minimum energy application. At ambient temperature, at room temperature, we should go or we should achieve number of synthesis. We should avoid the use of energy in terms of heating or cooling or any kind of stirring and all things, that we should avoid. Then 7, renewable feedstock. Dr. Actually, Dapre mentioned that point. We should avoid the fuel or fossil resources for various applications. So it means that we should avoid the non-renewable resources for application, but we should go for renewable feedstock. The agriculture waste or agriculture products are the best example for renewable feedstock. Renewable derivatives, unnecessarily protection, deprotection, one compound, A compound to B, B to C, C to D, C to D to E, instead of 4, 5, 10 steps. By avoiding these all steps, we should achieve the derivatization minimum steps or 1 or 2. Mostly in one step reaction or one step stoichiometric reagent catalysis is the proper way. Design time period, that parallel reactions. Unnecessarily, we should avoid 20 hours heating, 20 hours stirring, 20 hours refluxing and all things. We should minimize that period and we should achieve that reactions within a short period. Number of now technologies are available for achieving this reaction. And last one is the safety. If we go for from prevention of waste to real-time analysis, definitely we achieve safety and that synthesis is the ideal synthesis. That these are the 12 principles of green chemistry that has been constituted by Paul T. Anastas. Now these are the examples. I will not go in detail because of our already we are lagging behind as per our schedule. So these pictures, this is the reduction. What we should emphasize on the reduction of materials, energy, non-renewable resources, waste, risk, hazard, and cost, so that we can achieve this type of ideal synthesis. So this is the ideal synthesis. If you follow 12 principles of green chemistry. So as I said, solvents and auxiliaries. The first column, that is a green colored, water is in a big font size because it is a universal solvent. So we should prefer water as solvent. Then we should go mainly water mixture solvents are more preferred. And this first column, all solvent, water, acetone, ethanol, heptane, methyl, ethyl ketone, and butanol, all things. Second column is yellow color. If there is no substitute, we should go for cyclohexane, toluene, and other solvents. But we should avoid the last one totally. And unfortunately, the last column is the common solvents or chemicals in our laboratory. The last column, see, benzene. Benzene is highly harmful. We should avoid. It has been totally banned to use in the laboratories since last 10 years, even though it is a common solvent in our laboratory. So as expected by Dr. Dapre and mentioned also by Dr. Domne, principal, that we should go for good alternatives. So we should start from ourselves. So we just to create awareness among our students that these are the harmful solvents, these are the harmful chemicals. We should not use this chemical in our laboratory for practical purpose or research purpose. Then only we can achieve our target for sustainability. So this is about the solvents. These examples I have taken deliberately for research student and PG students, that natural compound monoterpenoids are simple compounds, and their derivatization results in the number of compounds that have different biological activity. So polymer support, micro-mediated reactions, then solid supported reactions. All these reactions gives the products which are also shaper through shaper dissipated solvent room temperature, but it acts as a solvent. Hello.
Sir, yeah. Sir, we have lost your screen. Can you please, yeah.
Okay. So these are the reaction that we have used in our research. In concluding part, we have seen the efforts that have been put by these two personalities, Rachel Carson up to 1960 and Paul T. Anastas putting his effort since 1970, and he has given rules in 1990 after studying all chemical physical properties and reaction conditions for the green chemistry, and he has coined for the first time green chemistry for our chemistry. And as per the expectation of Paul Anastas, now whole chemistry should be green chemistry. So they are organizing such events, webinar, seminar, workshop. Just it is to create awareness among the young generation about this green chemistry, to remove the drawbacks or to overcome the drawbacks of conventional chemistry. So we should change our approach. Now we should develop new courses at PG, UG, diploma courses that we should incorporate some concepts of green chemistry, and we should give idea to the student to create awareness among them about green chemistry. So we should, that point already mentioned by Dr. Dapre, that our chemistry practical should be actually based on green chemistry approach. My suggestion, in a regular practical, we follow the procedures as given in the books. Take 15 grams of A, then add 100 ml of this solvent, then add 20 gram of this according to the given procedure. If you follow the micro scale practical, we should suggest the student to go for 500 milligram or 1 gram reaction. Then definitely that is also comes under greener approach. Instead of utilizing the large quantities of chemicals in the laboratory for practicals, we should add it. We should go for micro practicals at micro level. This is also greener approach. Then we should arrange the extracurricular activities about environmental, that we celebrate National Science Day on 20th February. By considering or we should grab that opportunity to create awareness among the students about conventional chemistry drawbacks and benefits of green chemistry. Competitive events, poster presentation or oral presentation or talk on this, debate on these topics. So this is extracurricular activity. So whatever I am giving lecture, this is the one way to give idea about green chemistry or shaper chemistry to the young generation. So we should go for this type of approach. So we have to take some decisions. Already we have we have taken that decisions in 1970, since 1970, and we have changed our looking at overall chemistry. And since 1990, we are emphasizing on green or safe chemistry or eco-friendly chemistry. So if you see the application of pesticide during 1940 to 1960, 20 years, this was a wrong decision. Why this was a wrong decision? Because of ignorance of the harmful or actually this is the these are the lines given by our former president, late Dr. APJ Kalam Sahab. What is the secret of success? It is the right decision. And how do we get right decision? With our experience. And how do we get experience? With wrong decisions. So with the wrong decisions about the application of chemicals during 1940 to 60, we have actually we got to experience after publication of this book Rachel Carson, and since 1970 we took a lesson to minimize the environmental pollution to avoid the harmful effects, and since 1990 we have taken right decisions after publication or since 1990 we have taken right decisions, and because of these right decisions we are now in a good environment, that is not only pollution but other environmental problems also. And just one example I have given, that is ozone layer, and that was the first report in 2005 that ozone layer is repairing because of our right decision taken from 1970 and more decisions, right decision from 1990. So this is the overall the Kalam Sahab, which is perfect for the, if you see the history of our chemistry and especially pesticides contribution, the environment, environmental pollution and problems. So what is the actually lesson that we get from all this past history? That we should be simple in life. Nature is adequate to provide the need of man, but not the greed. This is the message given by Mahatma Gandhi, our father of nation. So if you follow the simple or simplicity in our life, then we can go hand in hand with our nature or whatever available environment. But we should avoid our greedy nature. That already I have said. Nature is adequate. Whatever available in the on this earth or in this environment, that is sufficient for us. Even today's population, if it is doubled again, then even that population double, that nature is adequate to meet the need of man, but not the greed. So whatever required for us, that we should take that enough amount from the environment or from these resources, and then only again by following certain rules like safer chemistry rules, then and then only we can go or we will be on the right track of sustainability, and we can preserve whatever available on this earth and around earth for our next generation. It is our duty to preserve all things for our next generation. So be simple in the life. So this is also one more good message by our father of nation, Mahatma Gandhi, that we should avoid our greediness. So whatever we have our needs, that we can meet whatever available in the environment. So with this message of our father of nation, Mahatma Gandhi, I thank once again the organizing committee, Professor Dr. Vikas Domne, principal of this college, convener of this 2 days national webinar, and head of the department, Dr. S.W. Dhapre, then organizing secretary, Dr. Samina Tadvi, and all other faculty members for their efforts for organizing this nice webinar on the most useful topic, that is a greener chemistry. So once again, we try to introduce all the delegates and participants with two personalities and their work, that is Rachel Carson as a Pounty analyst. So with this brief, I can conclude that we should follow green chemistry, and as I expected by 2030 there must be at least one course on PG course, MSc in green chemistry or MSc in sustainable chemistry at university departments. So with this, for our evolving life, we should go for green chemistry, and we should maintain our maintain the greenery on the earth by following these rules. So once again, I wish all the best for delegates, and I thank you all for. Thank you very much.
Thank you very much, sir,
Thank you, sir.
for your delight speech on green chemistry, history,
Samina,
development, and prospects.
Samina madam, may I have some a fraction of seconds to interrupt with you? Sorry
Okay,
for
sir.
it. Dr. Maulikar, sir, thank you very much.
Thank you.
Suggestions which you quoted, sir, we are very kind with your suggestion. And one thing, let me apprise all the participants that, sir, we have already begins with the microchemical quantity from 2015. म्हणजे म्हणजे आमच्या लॅबोरेटरीज मध्ये आम्ही बेन्झिनचा वापर नाहीच्या बरोबरीच करतच नाही, आणि आम्ही सगळ्या क्वांटिटीच्या लिटरेचर मध्ये दिलेल्या असतात. त्याच्या अगदी म्हणजे वी आर युजिंग ओनली 20% व्हॉट वी हॅव कोटेड इन द लिटरेचर.
चांगली गोष्ट आहे. आणि ते रेग्युलर प्रॅक्टिस करतो ना आपण 10 ग्रॅम 12 ग्रॅम.
हा सर, नाही सर आम्ही ते घेतच नाही 10 ग्रॅम वगैरे.
बरोबर आहे.
आणि सर आणि सर तुम्हाला अजून एक म्हणजे मला सांगण्यात आनंद होतोय की आम्ही सायन्स डे सेलिब्रेशनचा एक पूर्ण वीक आम्ही साजरा करतोय सर यावर्षी. आणि पूर्ण वीक मध्ये आम्ही शाळांच्या विद्यार्थ्यांना पण इन्व्हॉल्व करतोय, ज्युनियर कॉलेजच्या विद्यार्थ्यांना इन्व्हॉल्व करतोय, आणि रोज एक वेगवेगळे चांगले पर्यावरण किंवा सस्टेनेबिलिटी थीम ठेवून आम्ही सगळे वेबिनार्स ऑर्गनाईज केले आहे सर एव्हरी डे.
कॉलेज फॉर पोटेन्शियल एक्सलन्स वरून लक्षात येतं कॉलेज काय करतं विद्यार्थ्यासाठी.
सर तुमचे खूप खूप आभार सर आमच्या सगळ्यांकडनं. थँक्यू व्हेरी मच सर फॉर बिंग विथ अस.
थँक्यू व्हेरी मच.
या समीना, यू कॅन कॅरी ऑन. Hello.
Samina, please unmute yourself.
Okay.
Okay,
Thank
Samina
you very
ma'am,
much,
please.
sir, for your light speech on green chemistry, history, development, and prospects. Thank you very much, sir. Now, for technical session, we have resource person, Dr. Gaurav Gupta, sir, Assistant Professor, GTP College, Nandurbar. I am very happy to introduce Dr. Gaurav Gupta, sir. Sir has 15 years of teaching and 10 years of research experience. Sir has completed his postdoc working with Dr. Anand R. Kapadi, sir, on project funded by Rasayan entitled Metal Mediated Synthesis of Heterocyclic Compounds at Institute of Chemical Technology, Matunga, Mumbai. Dr. Gaurav Gupta, sir, has research thrust area Ionic Liquids, organometallic chemistry, cross-coupling reaction, specific heat capacity measurement using DSC, TGA, DTA analysis, biodiesel preparation using ionic liquids, inclusion complexes of urea and cyclodextrins, and many more. Sir has published 27 international and 12 national research papers in reputed journals, and 3 articles and 3 book chapters, and sir completed 2 research projects. He is going to deliver plenary talk on topic Ionic Liquids, a promising green and sustainable alternative to the volatile organic solvents for organic transformation. Gupta, sir.
Thank you, madam. Is I am audible to all?
Yes, sir, yes.
Thank you for the nice introduction, madam. First of all, good afternoon. And then first of all, I am thankful to all the authorities of the college for providing me this opportunity to share my views on green and sustainability. Madam, मला थोडं allow करता का, म्हणजे मी screen share करतो.
Oh, yes, sir.
Okay.
Sir, you are already enabled. Please proceed, sir.
Thank you, sir. Then, first of all, after the very good session by Professor Maulikar on green chemistry, he covers almost all those things which are associated with the green chemistry. But about this 12 principle, solvents or the choice of a solvent covers almost 8 to 9 principles of the green chemistry. If we are appropriately tune the solvent for the reaction, one can achieve the goal of this sustainability. That's how the solvents are very important. Okay, then what is meant by the solvents? What are the role of the solvents and why the solvents are so important in organic transformation? And the best thing is the water, the evolution of the life on this planet. The nature chooses water, which is as a solvent, and the biomolecules have been synthesized in the water, and then that we call the life. That exhibits the importance of the solvents and what the solvent can do. In organic chemistry in particular, when we are dealing with the organic transformations, we can convert selective transformation into the specific one or the specific into the selective one by just changing the solvent. That's how the solvents are very important. Halides or halogen-based solvents, they are catalyzes the degradation of the ozone. That is the main threat of the solvent, but still one cannot have the alternatives to these solvents for particular extent. In industries in particular, volatile solvents have been used, but nowadays the restrictions are there from the perspective of environment and all those the sustainable development. Therefore, alternatives have been tuned in the industry. But before that, why? What is the need of this green and sustainable alternatives? The one most thing is, as a synthetic organic chemist, Wooler, that he started this branch of the science that we call synthetic organic chemistry by synthesizing urea in the laboratory. This was the breakthrough to this vitalism or the vital force theory. And that time, everyone how very strange towards the discovery or towards the synthesis of the urea in the laboratory, because before that, one can know only God have the powers to synthesize these organic molecules, but we cannot synthesize these organic molecules, and this is called as the vital force theory. Berzelius, who was the mentor of Wöhler, is a strong follower of this vitalism and the vital force theory. But Wöhler gives the breakthrough to this theory and then synthesizing urea in the laboratory for the first time. Thereafter, too many developments have been carried out, and then the glamour of this organic synthesis, okay, have been awarded with the Nobel Prize to the Woodward, the father of organic synthesis. That was the time when Woodward from chemistry and Feynman from physics get awarded with the Nobel Prize. And in the press conference, one of the reporter asked him whose contribution to the Feynman. He asked the Feynman whose contribution is better, either Woodward or you. Then Feynman very notoriously replied, of course, it is Woodward. If he decides, he can develop a Feynman into a test tube. That's how this wonderful glory of this organic synthesis. But because of the greediness of some of the peoples, organic synthesis loses their glamour. This science of molecules, which have an ability to develop any compound in the laboratory, loses its glamour because of the greediness of the peoples. And then the silent spring in 1964, okay, by Rachel Carson is a milestone. Okay, the silent spring familiarized the people that we are not the only life forms present on this planet, but all the life forms with us have equally important that were created by the nature. And then after the silent spring, there are too many work on the sustainable development and the green chemistry development have been carried out. Then an asked us who suggested the 12 pioneering principles of this green chemistry, out of which the most important is the solvent. Because without solvent, we can't imagine the organic transformation. There are too many things are there, but solvents have a very detailed history. That was the times, or even in the ancient time, we are in search of a solvent which have potential to resolve all the causes of the diseases that we called elixir. In this time of alchemists, even there are some documentations are available that Newton is also involved with the alchemists to develop a menstruum universale. That is the liquid or that is the solvent which have a potential to resolve all the causes of the diseases. But there are too many trial and error experiments were there, and it is to be supposed that the death of Newton is that because of such type of formulations. But after the development, there are too many alternatives have been found out to just reproduce the glamour of this science of molecules that we call the organic synthesis. And then too many developments regarding the solvents in particular. Because nowadays, in the present, we breached all the thresholds of this planet from the perspective of chemical pollution. Everywhere we are just bombarding the chemicals to this, and then the figure in front of you. There are the percolations. If one can forget the ionic liquid, but all the chemicals should be percolated in the soils, in the groundwater sources, in the marine animals where the flora and fauna is also affected with that. Even the life forms present in the marine is get also accumulated the chemicals. And then here in this picture, there is ionic liquid. This ion stands for the ionic liquid. Why we are called ionic liquid are the promising green alternatives to the volatile organic compound. That is because of their non-volatility, because there is very less chance to escape this into the air. That's why they are non-volatile in nature. But when they are introduced to the soil or introduced into the domestic waste or any other waste, there is a possibility that this molecule can be absorbed, okay, or by uptake with the animals or with the different the soil or the groundwater sources or even into the plant. And then this is most important. We have tuned the ionic liquid in such a way that they do not have any toxic effects. That was the time when people talking about ionic liquids. All ionic liquids are not toxic, are not safer, or they also have a toxic effect. Yes, of course, it is accepted. The ionic liquids, they also have a toxic effect, but they have their permissible limits. Generally, the formulations with imidazole in particular, they are quite safer to the human beings also. Some surfactant ionic liquids, they are based on pyridine itself. They also have very good degradation mechanism, and then they are safer to the human beings also and other life forms also. The only good thing for ionic liquid is one can tune ionic liquid in accordance with our use. Okay, that tunability makes the ionic liquid much more their generalization in the laboratory. In the history of ionic liquid, that the ionic liquid, the first ionic liquid was coined by Walden, that is ethyl ammonium nitrate. But before that, there are too many salts that we know, but only this ethyl ammonium nitrate, which is liquid at room temperature, grabbed the attention. And then in this course, Osterren and his co-workers in 1975, they developed N-butylpyridinium chloride in the laboratory. Osterren is the man which is related with the electrochemistry, and he just developed electrolytes. And then they synthesized the N-butylpyridinium chloride in the laboratory. Then the team, the Osterren headed the team. The members are C.A. Angel and the Whites. These two focus their attention towards the generalization of more and more ionic liquids, out of which Whites, he focused his attention towards imidazolium-based ionic liquids. And then he first time coined the definition of the ionic liquid, and he separated the ionic liquid from the molten salt category on the basis of their melting points. And then he coined the definition that the salts which have melting point below 100 degrees Celsius are called as ionic liquid. And then on these grounds, ionic liquids have been classified as room temperature ionic liquids and functional ionic liquid, and there are too many things. Nowadays, we are in the fourth generation of ionic liquid, that is called as sponge or the surfactant ionic liquid. But similarly, the C.A. Angel, who also have a master class work in the by predicting the theories, by classifying the ionic liquids, and nowadays we have in the last decade or more or 2 decades, we have very good database present on the ionic liquids. Of course, all the formulations, they are not green or they are not safer to the life or to the human beings also, but we can tune these combinations of ions here. In the picture, some of the possible combinations are given. That is, in particular, imidazole-based ionic liquids have been widely accepted for their utilization. Nowadays, a tremendous database is available for ionic liquids, for the utilization of ionic liquid. As ionic liquid which are comprised totally of the ions, therefore in electrochemistry, they have their benchmark applications. Even to enhance the efficiency of the solar cell, some ionic liquids have been utilized during the manufacture of the cells. And then nowadays it is really efficient solar cell how we have at the time. Even in the electrochemistry, ionic liquids have been used to construct not only the solar cell, but there are too many applications in the cell material, of course. In the next, the science of molecule that we call as the synthetic organic chemistry. Very soon, or within a decade, the name of this organic chemistry has been changed with the science of molecule because we deal with number of molecules, the molecules which are associated with the life governing process and take part, very active part in this life governing processes, where ionic liquid can use as a solvent. Also, their Lewis acidity is responsible for their catalytic behavior, and ionic liquid work as a working catalyst for this, and therefore this dual applications of ionic liquid in organic transformation make them very feasible or makes them a promising alternatives to the volatile organic solvents. The most important thing in case of ionic liquid is their boiling points. They have very high boiling points and therefore a high temperature reaction also carried out in ionic liquid. Their inertness with respect to the transition metal catalyst is also one of the key factors that ionic liquids have also been utilized in organometallic transformations. And it is not exaggerating that ionic liquid played a role of bridge for the homogeneous and heterogeneous catalysis reactions because it is a part of the way that homogeneous reactions and heterogeneous catalytic reactions, which one is better? But ionic liquid can couple or can bridges these two transformations very significantly. Then in the material science, as you can see in the picture, there are too many applications of ionic liquids are there. Nowadays, even in the explosives, this as ionic liquids, ammonium-based ionic liquid having nitrogen. Therefore, their explosive properties have also been tested, and due to or by changing, but just functionalizing these ionic liquids, and we can get a safer explosive material also. In the rocket fuel, even with the lithium-ion battery, some ionic liquid combinations have been utilized to enhance the life of the battery. Nowadays, in the United States, desulfurization of fuels have been carried out by just using ionic liquid towers and just pass out the fuels and desulfurization is carried out. In environmental science, imidazolium nitrate-based sensors have been utilized to detect the nitrogen concentration present in the water as well as in the soil bodies. And then the most important in the life science, where the double helix is so important, or simply the ion can do a lot of things, as ions are responsible for the life and they are very essential ingredients of the life governing processes, where the ionic liquids, particularly histone, is well-known biomaterial which comprises with the imidazole, and this cottonization of this imidazole can lead to different functions. Then in the protein tagging and all those things which are very effectively carried out in the ionic liquid. Okay, ionic liquids are simple compound, just one can achieve by Minch-Kutin cottonization of tertiary amine. It is nothing but the cottonization of tertiary amines. In particular, the 1-methylimidazole pyridine, just in presence of alkyl halide, they give the cottonized product, which is called as the Minch-Kutin cottonization product. And then one can get the possible combination of the ions. This combination can be exploited in terms of the organic solvent or as an electrolyte or as in material science. There are too many applications have been advanced for this ionic liquids. Then, as there was a Salze, the well-known chemist, who first time asked the question to the Welton that are the ionic liquids are safe? Is really they have potential to be a safer chemical, or is they really have potential to alter the volatile organic compounds? As there are number of organic reactions have been already tested and how the protocols are very well accepted in the industries. Is really ionic liquid have the potential to replace them? Then, for this purpose, the SWOT analysis of ionic liquids have been achieved. In every industry, the SWOT. The SWOT means the strength, weakness, opportunities, and the threats. SWOT analysis is nowadays a part of every industrial practices. For example, any reactions or any classical organic synthesis is carried out in the organic solvent. In organic solvent, we expect that only, or we concentrate only on the yield. But what about the atom economy? What about the waste? Okay, which directly we thrown out. But when we are tuning the ionic liquids, the first thing is what are the strengths of the use of ionic liquids. And the first and most important is the tuning and designing ability of these ionic liquids. Ionic liquids provides this designing ability, therefore, these neoteric materials have been very widely accepted in industry nowadays. Then, as they provide a dielectric medium, okay, they are considered only the solid material which have its own structure after the water. On this planet, only water have its structure, or water is considered as a structural fluid, and thereafter ionic liquids. They have their own structures and they are considered as a structural fluid after the water. And therefore, due to their dielectric constant, they can provide a very good medium to these organic materials also. Sometimes they are quite problematic when we are tuning the reactions in water as a solvent, the solubility of the organic compound. But ionic liquids are the possible composition of ionic liquid having ability to dissolve most of the organic materials. Then energy efficient. Nowadays, we are focused on the sustainability, and the sustainability not only from the chemical process, but also from what type of the system, or what type of the reactor which we are going to use. Room temperature protocols or room temperature transformations have widely been accepted in the industry. If one can provide the room temperature alternatives to the classical organic synthesis, then this is well accepted. Then good mass and heat transferability, of course, that is related with the economy. And the most important is the solvent-free synthesis. As ionic liquids, which are liquids, their melting points or boiling points are very low. Sorry, boiling points are very high, but melting points are very low. They can provide an excellent solvent liquidous window to the organic transformations. Working catalysts on the basis of their Lewis acidity, they are considered as a working catalyst, and these are the reactions are the finest examples of the ionic liquids, where the organic transformation is carried out in the ionic liquid, because these are the reactions are carried out generally generally in the catalyst-free conditions. But once the ionic liquid have been added, even the specificity of the pericyclic transformation have been increased. And then high atom economy, that depends on the yield. Then what are the weakness? And these are the points of the strengths of the use of ionic liquid. But what are the weakness? Is discoloration, is decomposition, extremely specialized apparatus, lack of energy efficiency data, scale up not demonstrated, sometimes low yield and lack of selectivity. Yes, in the weakness, the most important is the discoloration during synthesis of ionic liquid. Though it is simple Menchikuttin quaternization reaction, or in the language of organic chemistry, it is nothing but a biomolecular nucleophilic substitution reactions, and of course, with the heteroatom. But the presence or under the normal conditions, the interruptions or the CO2 present in the atmosphere can cause the coloration to these ionic liquids, because as they are the salts, they are colorless in nature, but sometimes a pale yellowish color is to be developed. That is because of the carbon dioxide which is to be dissolved in that ionic liquids, or during filtration some impurities are there. Is decomposition. Decomposition, that it depends on the constituents. One can tune the constituents, high energy constituents also. Okay, that's one can minimize the threat of the decomposition. The decomposition from the perspective of the reaction conditions. If the reaction conditions are below 100 degree, then it is okay. If they are above 100 degree or 200 degree, then one can tune the ionic liquids or the composition of the ionic liquids accordingly. Then specialized apparatus. Nowadays, the data is well known in the literature that there are too many ionic liquids have been generalized or synthesized, which do not allow to the moisture. And then, of course, they are very easy to handle. There are too many reactions or too many synthetic routes have also been generalized that they minimizes the time for the synthesis of ionic liquids. The cost of the ionic liquids is the most important weakness during generalization of ionic liquid. But nowadays, the strategies are available in the literature that one can easily synthesize the ionic liquid in ordinary laboratory conditions also. That is not a big deal right now. The cost is important, that is because of these things. But between 5 to 10 years, that is a routine practice in the organic laboratories that to synthesize the ionic liquids. And it definitely will be the future of the laboratories that our shelf, which contains not the solvents, but the ionic liquids for the organic transformation. Then what are the opportunities to use the ionic liquid in? Green and sustainable process development. That is the first benchmark. Green and sustainable process. What is meant by the green and sustainable? That is sustainable. It is not from the perspective of only human beings. That is sustainable from the perspective of all the life forms those are present on this planet. Then quantitative energy input data. Most of the organic transformation in ionic liquid have been carried out at room temperature or ambient condition of temperature and pressure. Therefore, the energy requirements are quite less. Designing of reaction chamber. As their behavior is quite milder, therefore, no special type of reaction chamber have been developed. And then as the field is started from 1 or 2 decades, the intellectual property rights or the patents, there are very much scope for the patents and the exploration of ionic liquids. Then what are the threats? Again, the threats are quite similar with the weaknesses. The most important is the toxicity data. What about the toxicity? But it is fact that everything which is hazardous when it is in excess, even in water. In case of even water, if it is in excess, it has its hazardous effects, and therefore one can tune the ionic liquid that is according to the conditions. This is the SWOT analysis. Every chemist, though they are present for their research or they are registered for their PhDs, they perform the SWOT analysis before performing their reactions. Because the laborious work, or we are not supposed to do the donkey works. If we have very good literature or practices with the literature, our laboratory work is minimized manifold. Generally, the peoples from physical chemistry or from theoretical background, they considered organic chemistry, they are supposed to do only the donkey works. There are too many compounds, too many trial and errors, then column and all those things. One can the organic chemistry have been tuned. But one can minimize this laborious work, okay, by just simply going through such type of SWOT analysis. You have to make a habit for this SWOT analysis. Then how one can explore the ionic liquids? Very initially, this is simple Minch-Kutin cottonization reaction, that is synthesis of ionic liquids in short. We are using the template that is called as molten tetrabutyl ammonium bromide. Every laboratory have tetrabutyl ammonium bromide, but that is for different applications. Then when we are going through the Bockris and Reddy's book in ionics, they reported the ability of the molten salts. And then we are going through the TDA-DSC analysis of this tetrabutyl ammonium bromide. It is a well-known compound in the literature. And the beauty of this tetrabutyl ammonium bromide is it have a melting point 116 degrees Celsius and offers a liquidous range of about 60 degrees Celsius. Means once the tetrabutyl ammonium bromide is melt, this melt is stable up to 175 degrees Celsius and thereafter it decomposes or vanishes off. But this 60° provide a quite liquidous range. And then we tune the main coating quaternization in between this range. We made first this tetrabutyl ammonium bromide and added 1-methyl-imidazole with appropriate alkyl halide in a one class, and in the second class we added pyridine. And very surprisingly, within half an hour, we get a final product that is called as ionic liquid. Okay, by just treating it with the ethyl methyl ketone, and one can separate it, this tetrabutyl ammonium bromide from the resulting ionic liquid. But the important thing is, if we are going with the conventional organic synthesis, that is, this is a biomolecular nucleophilic substitution reaction, and one can use such and such solvent system for this. For example, we are using a protic solvent that is called as benzene or toluene or any analogous. It took almost 48 hours for the synthesis of these compounds. But within half an hour, we get ionic liquids in hand with extreme purity also. Then why we choose this tetrabutyl ammonium bromide? The most important thing is the toxicity data available for tetrabutyl ammonium bromide is very rare. That is, it is said to be it is quite safer to the human beings, and if one it is just introduced to the atmosphere, to the soil or to the water structures, there are no harmful effects have been addressed right now in the literature. And therefore, we first going with the thermal analysis of this tetrabutyl ammonium bromide, that is PGA, and the DST analysis of this tetrabutyl ammonium bromide. And one can convert this data into the specific heat capacity of this tetrabutyl ammonium bromide. Once with complete review of the literature, then we use this template, that is the molten tetrabutyl ammonium bromide, towards the organic synthesis. And then after synthesis of organic compound or after synthesis of the ionic liquids, one can establish the structure of this N-butyl pyridine bromide, which is associated with the 4 water molecules. And with the help of mass spectrometry, we can study the thorough structure of these ionic liquids, those we are synthesized, and then such type of dimeric interactions have been advanced. Then this is one sort of the utilization of ionic liquids as a reaction medium. In the next, then we are going with what happens or how one can introduce ionic liquid to the polymeric science. And then with Dr. Gite, we are just advancing a system, or we are just replacing one of the ingredients during the PVC formulations with the ionic liquid, and with the strange result have been obtained. One can synthesize or one can formulate the PVC with a high thermal stability when we assess it with the hot air oven test. And similarly here we use ionic liquids, that is a pyridine based ionic liquid. Generally, no one uses the pyridine based ionic liquid for polymeric purposes because N-butyl pyridinium bromide is not good itself for the polymeric formulations. By just changing the anion, that is, instead of Br minus, we are just replacing this Br minus with the PF6 and the BF4, that is tetrafluoroborate and hexafluorophosphate, and a sudden and quite interesting results we are advancing here. Then in the next, we just try to propose the mechanism as ionic liquids, which are when polymers, they are when exposed to the sunlight, liberation of HCl is carried out. But if ionic liquids are used during the formulations, this liberation of HCl or this step is extend up to 30 to 40 degrees Celsius. Means this zipper mechanism for the pure PVC, elimination of HCl from the PVC, is to be produced at almost at 100 degrees Celsius, but that can provide a window of about 150 degrees Celsius. That is the benefit of these ionic liquids. Similarly, when ionic liquid, one can use this with PVA and PVCs. It can break all sort of the hydrogen bonding interactions, and some new hydrogen bonding interactions have been found in between ionic liquids and the PVA molecules. Then The most with these results in our hand with the PVC and PVA, we focus our attention towards the polysulfide. What happens to the polysulfide? They are the most toughest chemical present nowadays in the organic laboratories that no solvent have an ability to dissolve these polysulfide polymers. The strong acidic conditions are required to dissolve these polysulfide polymers or strong alkaline conditions. But other than this, the possibility of dissolution of this polysulfide is very less. After that, no organic solvents having an ability to dissolve these polysulfide polymers. Then we turn our attention. This work we are associated with late Professor Mrs. J.S. Mishram from Nagpur University. Then this group, we are using simple ionic liquids for this purpose, that is tetrabutyl ammonium hexafluorophosphate and butyl methylmidazoleum bromide. And then the results are very surprising. This polysulfide polymer is at room temperature get dissolved or started dissolved into the ionic liquids, and a homogeneous solutions we have in our hand. And then all thermal as well as the morphological study shows that the polysulfide is quite easily dissolved. And then this degradation, we are proposing the mechanism that how the ionic liquid works and how it cleaves this sulfur-sulfur bond interactions, and new bond interactions with nitrogen and sulfur have been found. And their stability have been assessed with the help of thermal analysis. Both tetrabutyl ammonium bromide and the butyl methylmidazoleum bromide play the same role for this degradation or for the dissolution of this polysulfide polymer. Then in the next, after this success, we started work on the supported molten salts. Then how one can use the heterogeneity or heterogeneous catalysis. Then we simply coated the molten salt over the silica, and this is the morphological structures of this coatation, and then study their thermal behavior, and using this supported molten salt as a catalyst for the trans-esterification reactions. And the data is in our hand that the trans-esterification reactions with different supported molten salt, that is from tetraethyl ammonium bromide, tetraethyl ammonium hexafluorophosphate, tetrapropyl ammonium bromide, tetrapropyl ammonium tetrafluoroburate, hexafluorophosphate, tetrabutyl ammonium bromide, tetrabutyl ammonium tetrafluoroburate, tetrabutyl ammonium hexafluorophosphate. And then we have this data in our hand, that is for the final product of the biodiesel. As we know the biodiesel is nothing but a trans-esterification reaction. These supported systems or supported catalytic systems are very much favors this trans-esterification towards, or on the other hand, or over the conventional methods, those which are used for the development of the biodiesels. Then after the biodiesel is in your hand, we tried to check the quality of the biodiesel from the perspective of, or by utilizing the thermal methods. And then one can see that the biodiesel, the specific heat capacity data for the biodiesel and the blend, of course, it is quite, having similarity with that of the petrodiesel, which is readily available into the markets, but it needs more and more thorough study. Then next, after the 3 generations of ionic liquid, that is the haloaluminate, then diimidazolium, alkylimidazolium base, the combinations of this, and the next one is the sponge or the surfactant ionic liquids. This is much more important because ionic liquids having potential to just bridge the homogeneous and heterogeneous catalysis, because there are too many debates are there which catalysis is better and which is not. Then we tried with the sponge ionic liquid system. For this purpose, we used cetylpyridinium bromide for the first time. Cetylpyridinium bromide is a well-known surfactant. It also have biological applications in too many formulations, but particularly in the gargling agents cetylpyridinium bromide is a key ingredient, then in too many medical formulations, cetylpyridinium bromide is used. Therefore, we have a strong database over the toxicity or over the suitability of the cetylpyridinium bromide to the life forms. And we just going through the thermal analysis of the cetylpyridinium bromide, and we saw that cetylpyridinium bromide have a melting point of about only 60 degrees Celsius, below 60 degrees Celsius, and then we consider this as a ionic liquid, as it have a carbon chain more than 6 carbon, therefore one can consider it as a sponge ionic liquid. Though cetylpyridinium bromide is a well-known surfactant, therefore we call this as a surfactant ionic liquids. After considering its thermal analysis, one can calculate its specific heat capacity details and a uniform pattern have been obtained. Therefore, we are very confident about the use of this cetylpyridinium bromides. Then the morphological studies of the cetylpyridinium bromide, once it is with the palladium acetate, they are here. Then on the basis of morphology, we can't predict the reactivity, but it can give an idea about the structure or morphology of this particular component. And then we tune here the synthesis of the aminothiazole compounds. Different ionic liquids have been used, but the most interesting is the use of cetylpyridinium bromide. For the first time in the literature, we use this cetylpyridinium bromide as a solvent system in the organic synthesis. And then the compounds are obtained in good to excellent yield. They are characterized with the help of the spectral details and all those things. Thereafter, the cetylpyridinium bromide is exploited in or cross-coupling reactions also. In the Hake cross-coupling, the results are sound there, but due to time limitations, I am not incorporating these sites here. This is our group. That is impossible to collect such scientific data without their involvement. Actually, our group is called as Professor KDP's group, is a well-known Humboldtian and the physical chemist. Then we are in the ICT with Professor Maiti and Professor Kapri. And thank you for your patience. And then I'm ready if you have some questions.
I think there is no question, sir. Thank you very much, sir.
Thank you, madam. And all the very best for this national webinar to you. Thank you, sir, for providing me the opportunity. Thank you very much.
Thank you very much, sir, for elaborating our knowledge in green chemistry. Now, I may call Dr. G.B. Tiwari, sir, Assistant Professor, Department of Chemistry, J.M. Patel Arts, Commerce, Science College, Bandara, for giving vote of thanks.
Am I audible, madam? Hello, am I audible?
Yes. Tiwari, please proceed.
Okay, thank you, sir. So it is my privilege to propose the vote of thanks in the day one of the 2 days national webinar on green chemistry for sustainable future, organized by the Department of Chemistry, J.M. Patel Arts, Commerce and Science College, Bhandara, under DBT Star College scheme. We express deep sense of gratitude to the very respected principal, Dr. Vikas Dhomne sir, for blessing us with his words of wisdom. Thank you very much, sir, for your constant encouragement and support in organizing such programs. We are indebted to the inaugural and keynote speaker, Professor Dr. P.P. Mahoulikar sir, ex-pro Vice Chancellor, Kavitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon, for enlightening us with a very informative and excellent presentation on green chemistry, history, development, and prospects. Thank you very much, sir. We are also thankful to the resource person of the technical session 1, Dr. Gaurav Gupta, sir, Assistant Professor, Department of Chemistry, G.T. Patil College, Nandurbar, for highlighting the importance of ionic liquids as promising and green and sustainable alternatives to the volatile organic solvents for organic transformations. Thank you very much, sir. We are grateful to Dr. Karthik Panikar sir, Coordinator IQAC, for highlighting the need to develop green technologies in his address. And we are also thankful to Dr. Panikar sir for technical support in the organization of the national webinar. Thank you, sir. I am thankful to Dr. S.W. Duffrey sir, convener of this national webinar, as well as coordinator, DBT Star College Scheme, and head Department of Chemistry for their valuable introductory remarks. We express our thanks to Dr. Padmavati Rao, Head Department of Botany, Dr. Veena Mahajan, Head Department of Zoology, for their presence and support. We feel short of words to express our gratitude to all the participants in this national webinar. We are thankful to all the faculty members and student participants of J.M. Patel College, Bhandara, teaching faculty members and students of our beneficiary institutes, M.B. Patel College, Sakoli, S.N. Moore College, Tumsar, Nutan Kanya High School, Bhandara, Bansilal Lahoti, Nutan Maharashtra School, Bhandara. Thank you all for your constant motivation and support. We are also thankful to the student participants of J.M. Patel College, Bhandara, for their presence. On behalf of the organizing committee, I express my indebtedness to all those who directly or indirectly help us in organizing this national webinar. Last but not the least, I express my deep sense of gratitude to the Department of Biotechnology, Ministry of Science and Technology, Government of India, for awarding us with DBT Star College Scheme. Thank you. Thank you, sir.
Can we conclude now?
Yes, sir.
Okay. Okay, so good day to all of you and see you tomorrow.
Okay. Thank you, sir.